So I know what you're thinking. Isn't the NanoKVM just another Chinese backdoor? If you watch Andrew Perlardi's video on the NanoKVM, he did a deep dive in the security aspects on several NanoKVM products, and he did a really great job of looking at Wireshark and even doing some reverse engineering and binaries, which are impressive skills that I do not currently possess. And I appreciate the level of detail he went into to check out the security aspects. And this video, I'm going to be looking at the NanoKVM USB version. The USB version, I believe, operates differently than some of the other NanoKVM devices out there because the software is not hosted on the machine itself. And you have to host it either on your local machine, a machine on your network, or even in the public cloud if you see fit to do that. And I recommend, of course, if you host those kinds of things in the cloud, that you secure it properly. You can add your own authentication or whatever in front of it. But this app does not have any authentication or anything like that because it's designed just to run on your local machine offline. It doesn't require internet access to use. But I'm going to take a look at that in this video later. But I wanted to have this quick little intro since his video dropped before I finished this video. I think this could potentially be a more secure, viable option than some of the other NanoKVM options out there. But we'll see when we get into this deeper later in the video. So Sipeed is the creator of the NanoKVM devices. These are all RISC-V based IP KVM devices, and they're pretty interesting because they're very affordable, very compact and tiny, and allow you to control your computer remotely very easily with a dedicated device. The advantage of a dedicated device versus using VNC or similar type of software is the fact that you can usually power on the device, and the device can see your BIOS screens and everything before the operating system boots up. That's the big advantage of having a dedicated device. This is kind of similar to how devices have IPMI management on server motherboards, where you can control the machine remotely and boot it up and power it up. Not all IP KVM devices allow you to power on and power off the system via the power switch. So keep that in mind depending on which models you get and what kind of features you want. So Sipeed has created several different variants of the NanoKVM, which is great because it gives you some flexibility in how you want to deploy your remote management solution depending on what your needs are. And I really appreciate that. And I decided to select the USB version one because that allows me to, as I mentioned in a previous video of a USB KVM, allows me to play with devices at my desk, or I have a computer here, for example, that I control all of my management of my network on its own dedicated network, and I don't want to have to open up any firewall rules between them. I can keep it truly isolated on that network. So if I have a USB KVM, I don't need to worry about having to route things through the firewall if it's down for some reason. I'm trying to upgrade or swap out of some hardware or whatever, and I can't get direct access across the network, across the VLANs to get to it. So that's my use case that I'm interested in and trying out, because I have several IP KVM devices in my server closet, and I like having network access for those type of devices because it's not in the same room as my desktop. I definitely appreciate Sipeed and others sending me these types of products, and I hope you guys appreciate the technical details I talk about in some of the videos more, especially when I try to do some demonstrations with it, because I'm not trying to just market and sell things. That's not really my goal. I'm interested in the technology. That's what I like doing. I like playing around, tinkering with this stuff. The products themselves are just the means to do some of these things. So with that said, Sipeed did send me this product free of charge, and it's not paying me to do this video, just like on my other reviews. Most of the time I just get a free product to try out. So the NanoKVM USB, if you get the full package, comes with this nice little carrying case. And when you open it up, you have the NanoKVM itself and all the cables that you need. And look how tiny this is. It says it's finger-sized KVM, but it's more like a thumb, but it's close enough, right? So there are sides on here that are labeled for host and target. Host is the machine you're controlling from, like your desktop PC, and the target is, of course, the machine that you want to control. And there is a little button on the front of this, I'll show a close-up of this, that allows you to switch between the target and host, because there's a USB port on the back side that you can plug in a thumb drive so you can share files between the two machines. And what's interesting about this is you have an input for the target machine for the HDMI, and on the host side you also have HDMI ports, so it does HDMI pass-through, so you could connect an additional monitor in addition to the computer you're controlling it from. So if you want to have a second screen just showing what's on this target machine on that screen, you could do that. One thing I noticed in the specs is that it accepts a 4K 30 Hz input, and also puts a 4K 30 hertz output. So you can get 4K in and 4K out, but it says the USB capture is only at 2K, which is more than 1080p, but it's not 4K. So I guess that means it's going to downsample to 2K from 4K. That's probably going to be okay for management purposes. So the NanoKVM comes in 3 different colors. As you can see, the color they sent me was this nice blue color, which I like that color. But they sent me a shell of the 2 other colors, so you can get a feel for what they look like. And there's no electronics in these, so I'm leaving it in the cardboard boxes they came in, because the plastic pieces and buttons just fall right out because they're not attached to any electronics inside. So you see there's a black option and a red option. And the red option might look a little bit orange on the camera depending on the lighting, if I don't get that adjusted well at post-production. So next I'm going to show you how to connect the NanoKVM to the host and target machines. And I'm going to show you how to use their software. They created a web-based software, which is great because that gives me high hopes that this will work across platforms, a lot better than having a bunch of different native apps that have varying support across the different platforms, because it's hard to maintain all of that. And one thing to note is, even though the USB KVM doesn't require network access, if you want to use their hosted web app, you need to have internet access on the host machine at least. The target machine doesn't need to have internet access, but there is an option to download the web page basically and host it locally on your machine, or you can host it on your local network, which is pretty cool. They give you the option to control it 3 different ways, and basically in the cloud on their system, or on your local system, or you can locally host it on your network. And so you have those 3 options. So if you want true local access, you can install that web app on your laptop or PC and take it with you. I'm glad they gave that option so you don't have to use their website. So that way you can truly use this solution offline, even though it's web-based. I'm going to be using these 2 mini PCs as examples. On the left will be the target machine, and on the right will be the host machine. You will want to plug in the USB cable into the host machine into the host side of the NanoKVM. Next, you'll want to connect the USB cable to the target side of the NanoKVM to the target machine's USB port. And then you'll connect the HDMI cable to the target side of the NanoKVM to the target machine's HDMI port. And here is all the connections in one shot, so you can see everything. There's actually not very many cables you need to connect. The host machine should have a mouse and keyboard as well, but I'm not showing it in this video. As you can see, I have the NanoKVM USB plugged into the RATA X4 on my desk here, and I have HDMI on that side coming from the RATA X4, and I have the HDMI pass-through. I'm testing it out on my 4K monitor to the right. But on the left here is the screen I have set up with the web browser on my desktop of my host machine, and I just hijacked this monitor here on the right, which is hooked to my main desktop as well, and it's a 4K monitor. I just wanted to see if the resolution looked like it was nice and crisp, and it looks like it is so it's just passing the signal through, the 4K signal, which is great to see. But when it scales it down to 2K or 1080p from 4K, it does not look super great, so I would still recommend using a 1080p resolution. If you go to the wiki.sipeed.com/nanokvm-USB page, it will take you to this introduction page you'll see before us, and it gives you a little brief intro and all the interfaces and the different specs for this device. And the quick start shows how to connect the device like I went over just recently. But what you want to go to is go to the development page, and this will tell you how to set up a local deployment, a local network deployment, and a public network deployment. So they give you 3 different deployment options for this NanoKVM USB web page, which is pretty cool. First one I'll show you is a local deployment, and it's very simple, especially if you're using Linux and you already have Python is typically installed by default for using Ubuntu, for example. So if we want to use that instead of Node.js, we can do this Python service option. So let's do that because that's the simplest. So the first thing we need to do is go up here to the web files and click it so it downloads it. As you can see, it downloaded it to the downloads folder. So now I have a console window open, and I'm going to unzip the contents of the file. You can do it through the graphical interface if you want, but I'm just going to use the command line just to keep it simple here. Unzip NanoKVM. And so the file is now unzipped. So let's go into that folder, go NanoKVM USB, and I'll go back to the web page here, and you'll see that it shows that all we need to do is type this Python command. This is using Python version 2, but all you have to do if your machine has Python version 3, you can say Python 3 and then enter this command. So that's what we're going to do next. So we're going to do Python 3-m http.server, and then we're going to give it a port number that we're going to use, and they just use 8080 by default, but you don't have to do that. So now that the web server is running, we'll be able to access this web page and control our NanoKVM device. You're going to need a web browser that supports web serial like Chrome, and it also works on the Brave browser. I tested it out. And so you want it to go to localhost 8080, which I have typed up here, and hit enter. And it's going to bring up this box that asks for permissions. And you want to make sure you select USB 3 video for the video, and also USB 3 video analog stereo for the microphone, which that's kind of weirded me out a little bit when I saw I was using a microphone, but I think that's how it's capturing the audio from the target machine through the HDMI cable. So just make sure you don't pick your microphone, because you'll get feedback on your computer. And if you're also worried about someone being able to access your microphone, especially if you're using Sipeed's website that's publicly hosted by them, you might not want to make sure you don't use your microphone, just in case. You never know who could be listening in on that. But for your local network, it shouldn't matter as much, but make sure you pick the analog stereo option. And so we'll just do allow while visiting the site, and to give permissions, and then it's going to bring up this where you select USB device. So now we're on the web page is asking for it, and you'll see that my webcam also shows up on there as well. But we'll just pick USB 3 video, and then we're going to select the serial device, which is going to be our USB connection to our target machine. So if we scroll down, we want to pick the USB serial TTY USB 0 and click connect. And so now we're connected to the machine, and I'm on an Ubuntu machine, and you can see I can open up the terminal window and start typing on here, and you see the latency is pretty good, because as soon as I stop, it stops. It's very good. The picture quality is pretty decent. I wish you could turn up the settings just a little bit, because you could see in the text here there's a little bit of graininess to it, but I'm also zooming in on the web browser for this as well, so that you can kind of see what this looks like. There is a full screen option to get rid of some of the taskbars here. So you're going to want to make sure, if you want this to take up full screen, you're going to make sure you have to use the zoom in the browser, because if I full screen this, you'll see that it's not really, it doesn't increase the size of the actual screen that you're looking at. So that's something I noticed, that as long as I increase it on here, and yeah, it works. Yeah, so if I go and change this to a higher resolution, which this is 2K resolution, I'll show you what it looks like. You see how this fonts, it doesn't scale down very well, but it does let you select that resolution. You can even do 4K, which is this resolution, if I can see it properly. So you can see the text gets tinier. 4K actually looks a little bit better than the 2K resolution. So it does scale down, which is great if you don't want to interfere with the original resolution of your monitor, because some of these IP KVMs or USB KVMs, if you have a higher resolution set in there, you won't be able to see the screen because it doesn't do any downscaling. So I'd like to see this scaling work a little bit better. So I don't know if that could be a software update or if it's a limitation of the hardware being used, because it's low power RISC-V hardware. So I'm not sure if it's just a limitation on how it converts for performance reasons. It's kind of usable, especially if the fonts are bigger. If I go in here and make this, I don't know if I can do that. Yeah, so if I do this, make the font size a little bigger, you can read it. So just something to keep in mind. So if you're using the pass-through option, you can leave it at 4K and still be able to manage the device if you want to do some lightweight management on here, even though the screen quality isn't the greatest at this resolution. So I noticed if I go back to 1080p and I hit apply, the screen looks really fuzzy, like worse than it did before, and I realized that the refresh rate is set to 120 Hertz and it needs to be set to 60. And once you set it to 60, it will fix the screen. It's a lot clearer and more crisp. So that was something that was kind of interesting there. It's probably how Linux is detecting this USB HDMI adapter. And so this might not happen if you're using a Windows machine as your target, but just keep that in mind if something like that happens, that you might have to do a little bit of fiddling around. But we got back to 1080p. So the controls at the top are pretty simple. You got the screen resolution where you can pick 1080p on your device video, and this lets you pick your serial console USB device, which we already have selected. And then we have the keyboard controls where you can paste in commands, and you also can bring a pop-up keyboard here, which is nice if you need that. And then for mouse, let me close this out. For mouse, there are some controls up here where you could do different mouse mode like absolute and relative if you're having problems, and there's some different cursors you can use besides the default cursor to make your mouse stand out more. So if I pick that, you have to see how my one on my host machine, it looks different than the target machine. Sometimes that's useful. Default cursor is usually fine for me. That's why you see that little lag with the cursor. And then up here is this language, so you can go to English or Chinese, and full screen, which I already showed. And the X up there just minimizes this top panel here if you don't want to have it open, so you can just do that. I don't know if you can notice this on the video capture screen, but I feel like the contrast is a little bit high, so some of the colors don't look quite as natural as they do on the target machine screens. So what I'm going to show now is a local network deployment, and this is going to be a little bit different than setting it up on your local machine because it's going to require you to generate a certificate and use HTTPS. It's nice that they require you to do that, but it requires a couple extra steps. So I have a Proxmox LXC created, which is called NanoKVM demo, that I have over here that I'm going to be using to follow these instructions. So what I'm going to do now is download this web file from Sipeed's website. So I can do wget and then paste in the URL for that and just hit enter. It's going to download it, and then I'm just going to unzip just like we did before on the local deployment. All right, so and then we'll go into that folder, and if we go down here, you'll see that we need to run this command here, the OpenSSL command. So you should be able to copy paste this and hit enter, and it's going to ask you for different like country names and all that kind of thing. You can really skip a lot of this if you want because it's just a self-signed certificate. All right, now that the certificate's generated, we're going to create, since we're going to do Python, we're going to create this file called server.py. So just do nano server.py, and then it'll bring up nano, and then we're going to paste this in. Actually, there's a copy button here. You can right click and hit paste. And then Control O, enter, Control X, and then what we're going to do is just type python server.py. So instead of typing in the http.server Python that we did up top here, instead of doing this command right here, we're going to be running this script, which will have those commands built into here. Okay. So now we're going to do python 3.server.py. All right. So now it says it's serving on HTTPS, and we should be able to get to it with our browser window. So whenever you visit the URL up here with the HTTPS, you'll see it's going to say your connection is not private. You just hit advanced and proceed. And then we'll pick our device like we did before. Select serial device, connect. Sometimes you have to do this resolution. I did it more than once. All right, and so now we're back to our screen here that we had before, which is great. So it works on a locally hosted machine. So I decided to look at some of the security aspects of the NanoKVM-USB to see if it has some of the same issues as the non-USB versions that Andrew already took a look at. And I feel like this NanoKVM might be a little more secure than some of the other devices just because the web app is hosted separately and you don't have to worry about random things running on the device like Tailscale. And it's not trying to reach out. It's not trying to punch holes in your firewall. It doesn't have remote access. It's designed to run locally on your machine. And it only uses the web app through the web browser just to access the web serial functionality of the web browser to route all of the HDMI, audio, and USB traffic through the USB cable. So in some ways, I think this device should be a little bit more secure. But I'll dive into that, show you what I checked out, and then show you what I found, and see if there's anything else that we could look into further, as there's some other people that are definitely more skilled in that area than I am. So I appreciate all those who do look into these types of things, because I think it's important to make sure our devices are secure, that we're running on our networks. So with that said, let's take a look at some of the different things that I tried out to see if there's anything happening on this device. I tried on some Wireshark on my host machine, but there's so much traffic and just other things that I have going on my machine. I can do some filtering and stuff. It's just a little bit hard to isolate the traffic to see if anything's coming out of that web app. So I decided to put it on a container on Proxmox, so it has its own LXC that only have that web app installed on it, nothing really else. That really helps a lot with analyzing the traffic because there's nothing that's occurring there except for like doing Linux updates or whatever I'm doing on there and just setting up the web app. And the only thing I noticed was it accessed the DNS for and the server for the CDN for Sipeed's website so that I could download the file. And so that was the only thing I noticed. And I even left it running overnight and I didn't see anything calling out in the middle of the night, or at least within a day or two's worth of traffic that I looked at in there. I also took a look at the OpenSense firewall logs as well to see if there's anything in there. All that stuff should also show up in XenArmor as well. It's just a little easier to kind of filter and look through the XenArmor logs sometimes than it is the firewall logs that come with OpenSense. But I decided to check out both just to do some due diligence. If you download the web app and you start digging into the files, and you'll see in there's a JavaScript file that's rather massive, and it looks like some of the functions might be a little obfuscated. It's to kind of maybe minimize the size of the file. And I think they're using some React.js libraries and that kind of thing in there. So that might be a point where you might want to study that and look into that further, but that's a lot of work to go through that JavaScript file there. So it's kind of easy just to look at the traffic coming out of there. But if you're really worried about security, that's something you might want to do is evaluate what libraries they're using in there for the web app. One important thing to note is this web app doesn't have any authentication to it. You just open it up. So it's intended to run on your local machine or maybe even your local network where authentication isn't quite as important unless you don't trust the users on your network. But you can remedy this by using any kind of authentication software that's out there. You can, a lot of people like to use it in front of all their web apps. You can just use that same authentication mechanism before it lets you into the web page and web app. So I hope you guys enjoyed this video, and I tried to show some technical details and demonstrations of these types of products and not just talk about what's on the spec sheet and what it shows, so you can be a little more informed if you're interested in these type of products, if you want to have them for your home lab and home network. I really just like tinkering with stuff, and you can't really tinker with stuff if you don't have anything to tinker with, right? So that's why I like trying out some of these products when I have the opportunity and see how well they actually do. Until next time, I'm Dustin Casto, and I'll see you in the next video. They sent me just the empty shells. Let me get them over here. Of the, ooh. And if you want the toolkit, which I'm assuming is all of this,